Welcome to Figure Feedback. My name is Jeremy, and this is the Raise3D E3. In this video, I'm going to tell you a little bit about this printer. I'm going to run down some really quick specs and want to share with you what my experience has been like using this printer, show you some prints that I made with it, all that good stuff, and just giving my opinion along the way. But let's just kind of get the big facts out of the way. There are two print heads that's on the same rail, and you can enable a few different features to take advantage of that. For example, you can do what I'm doing right now, which is printing the same model on each different print head. So it's a duplication mode. Or you can do a mirroring mode so that you can have one particular object in a certain orientation and then you can mirror it for the other print head to print. You can also do dual color printing without any like purge waste. And then you can also do dual material printing as well, such as if you print with one material, let's say, PLA, and then you use PETG for supports. Last time I checked, it is selling for $2,500. That is for this printer here, and it has a maximum build volume of 330 millimeters by 240 by 240 when you use one of the tool heads. But if you use both of the tool heads, it's going to be 295 by 240 by 240. So the build plate is really more rectangular than the square build plates that we're used to seeing on the vast majority of consumer-based 3D printers. The nozzle inside can get up to 330 degrees Celsius, and it uses nozzles all the way up to a 1.0 millimeter nozzle, so putting out some pretty fat lines of filament. And then the bed can get up to 110 degrees Celsius. It also comes with a HEPA filter with activated charcoal. The touch screen is 7 inches with the 1024 by 600 resolution. Is a resistive touch screen. And then it also has USB ports, a couple of them. There's Ethernet. It has a built-in camera on the inside, and it also has a chamber light on the inside as well, so that you can monitor everything from the dedicated slicer that you have to use, which is called Idea Maker. And then this thing up top here is an optional accessory that's specifically designed for printing flexible materials such as TPU, all the way down to 80A shore hardness of TPU. And this is called the Flexible Filament Auxiliary Feeder. So like I said, it's a separate accessory. I'll show you how this whole thing works, but it enables you to not only print those types of filaments more successfully, but it also helps to speed up the process of printing with those particular materials as well. Now, when I got this delivered to me, it came very well packaged. It came in a really big box secured to a wooden pallet that I still have not gotten rid of. So it came very secure in its shipping, and setting it up was not difficult as far as taking out the different brackets that's used to hold some of the parts in place. You do that. It takes really no time. You'll be able to plug it in, and then you can start things up. Then after you plug it in, it has to run through a calibration process, which is something that we're all used to at this point. One thing that I was not expecting when I got this printer is before it could really go through the auto leveling process, it needed me to help set the Z offset of it using a feeler gauge that comes with the printer that is like a, basically it looks like a metal credit card. And you have to use that in a way that you would use some of 3D printers of the past, when you have the nozzle and you lower the nozzle, and then you have to keep lowering it until you feel a resistance in that feeler gauge. And then at that point, you say, okay, this is a good spot for it. And then the printer runs through some calibration prints to sort of ensure that that Z offset is set properly according to what you feel is the correct look for the grid of squares that it produces, that you're supposed to hold up to the screen and look for any type of light leakage. And when you don't see light leakage, then that's supposed to indicate that you're good. Your Z offset is good. And you have to do that with both nozzles. That's something that I really wasn't expecting with this printer. I did think that it was going to handle the Z offset by itself as well as the auto leveling by itself, because that's kind of what printers do in 2025. And this printer was also released in 2025. So that was the first big surprise with this. The second surprise, albeit not a very positive one, that I had with this 3D printer was that in order for you to get the left print head and the right print head to be able to do the duplication printing or the mirror printing, then they have to be within a certain tolerance of each other as far as their Z offset. And if those two are too far away from each other, let's say if the right nozzle is down too low or if it's up too high or vice versa, then when you try to use that dual mode, the printer is going to tell you that it can't do it because the offset between those two print heads is too far apart. And that's something that I really had to dig into to try to figure out what was going on, because that was my problem. So I got in touch with support from Raise3D, who instructed me that I basically had to disassemble a little bit, not a whole lot of disassembly, the left print head to the point where I was able to lower it manually and then retighten it so that I can run those calibrations again. And that involved taking off the print head that has some screws inside of it. And then there's this metal piece that surrounds the nozzle that you have to also unscrew in order to get to the nozzle itself. And then once you do that, you're able to just manually wiggle the nozzle and move it so that it can be a little bit farther down. Then after I did that, I reran the test and I was able to get those tolerances within a reasonable amount so that I could use this feature that you see here. And it has not given me problems in that particular instance since then. Once that was all settled and I felt more confident about actually putting some filament in here and trying out some prints, then that's when you kind of get introduced to where you load the filament. So on each side of the printer, you have these doors here that on the inside are compartments that's going to hold the filament. One for each side of the printer to correspond with the nozzle that's on the left and the nozzle that's on the right. And the way that you feed the filament into the machine, it's a little bit awkward, but it's not like difficult or anything, because you have to put the strand of filament up through this little port here that's like kind of on the side. And then that means that you have to unravel the filament maybe a little bit more than you might be used to, just so that you can just get it started going up into that path. And then you'll be able to put the filament in here, and you can put the spool holders configured in different ways to kind of just suit what you're trying to do to make it more comfortable for you, or maybe it depends on the size of the spool that you're using. And then you run all of that through the PTFE tube that's connected on the inside, and then you run that into the print head itself, and then you do the same thing for the other side. And then also inside of these compartments are not heated because this printer does not have a heated chamber. So instead, they have this desiccant box right here that comes with it that's also 3D printed that you can put desiccant into, and then you just slide that underneath the spool, and that helps to absorb some moisture that might be gathering inside of the individual compartments where your filament is. And then also, just before it slips my mind, if you want to move this printer around because it's so big and it's heavy, they do include these handles on each side. So, if you are strong enough, you can just grab it, pick it up, put it on your surface, or if you need some help, then each person will be able to grab each side. It makes it a whole lot easier to put on your table. And then also, if I could just move this auxiliary feeder out of the way, it also has this door on top that you can lift up. Makes it easier for you to access the print head and whatever else that you might need to access from the top. And then it's also recommended when you're printing PLA that you have this up. Like, look, it's done. Or you open up the front door in order to prevent heat creep. So that's something that you can do as well. So as is tradition, I started things out with dual benchies here. So this had some white filament here along with some blue filament, loaded it up and was like, hey, print 2 benchies at one time. This is how they turned out. They're just benchies, you know, nothing crazy about it. They look fine, but this was just me trying to test out the IDEX system, printing with 2 different color filaments, printing the exact same model at the exact same time. So the way that this turned out, I was pretty okay with it. No problems at all with the benchy. Then I printed this drawer pull here because I figured this is something that someone would do when they're looking for a more industrial thing. You're going to print some parts that are useful, modeling, prototyping, that kind of thing. So I got this drawer pull here. And I printed this out of nylon carbon fiber. And then when I was done with it, I just I painted it with a clear gloss. I didn't try to clean it up or anything. In looking around it, it looks pretty good for the most part. There's some rough edges kind of like down here. This is nylon carbon fiber, and I don't think I dried it all that much before I started to use it. So anomalies are to be expected. So I'm not going to blame the printer on that. But here's the other thing. After I did this, I realized that by default, this printer comes with a brass nozzle and not a hardened steel nozzle. There is an option to purchase the E3CF package that does include a left print head that has that silicon carbide nozzle in a 0.6 millimeter size, as well as the auto leveling system assembly. And then you also get that silicone carbide nozzle assembly for the right print head as well. Or optionally, you can just purchase the hardened steel or silicone carbide nozzles and hot ends separately. I'm okay with how this turned out, but I was also disappointed that it didn't already have a hardened steel nozzle right out of the box. Speaking of right out of the box, I printed this little box, just kind of like in the inspiration from those little tiny Home Depot boxes that they sell now. So I decided to just print this out of some regular old PLA. And inside, I just keep some little screws and stuff in here. And I think this box turned out fine, you know? The first layer looks okay, not bad. And then, you know, putting the box on, it snaps down in place. All right, little tiny storage box. That's all good. I printed a couple of things out of the nylon carbon fiber, and this is just it's a little belt buckle kind of mechanism. You know, it just slides in there. You get it in the correct orientation, and it does snap into place. So I'm see if you heard that. It snapped into place. Let it go. Do like that. You got to get in the correct orientation, otherwise it will not work. But boom. It's a simple belt buckle mechanism here with nylon carbon fiber that snaps into place. Tolerances seem to be good enough, at least for this. Now, these were the only things that I printed from that nylon carbon fiber. And just for fun, I also decided to print like this little mask. It's only big enough to fit like a child. Did this with some of the white filament here. And while it came out, you know, okay, you can definitely see the layer lines in this mask going from the bottom all the way up. You can definitely see it more prominently because this is white, especially when you get it in the right light. But hey, this is the raw product coming off of this machine. Then wanted to put this auxiliary feeder to the test. Now, this is something that when you want to print TPU of 95A, 90A, 85A, 80A, I printed PEBA with this thing. The way that it works is you have to take out these little black stoppers that's on the top of this lid here, and then you have to remove the PTFE tube from the inside of this printer, and then you have to guide the flexible filament through the ordinary spot. And then when it comes out, you have to push it through one of these holes here and into the in port of this machine. So this is what they sell to do this. And this has a 3D printed enclosure. And then it says in and out at the bottom of it. So you have to feed the filament in through here. And this is also powered. It comes with a power adapter. And I'll show you like what the inside looks like. So you can see like all the wiring and things like that. And it has this little silver button here that when you push it down, it grabs the filament and it just pulls it through rapidly. And it goes out through the out port, down back into the chamber. And then you take that filament and stick it directly into the print head. And as the print is going, as it's using up that filament, as that tension gets tighter, it triggers the mechanism in here to feed more filament through. It powers itself for like a second just to shoot more filament through, and then that process just sort of repeats itself. So that's how this works, and it has to sit here at the top of the machine. So if you want to, try to prevent heat creep as much as you can, then you would have to open up the front door just to let a little bit more air in. So I decided just to use just straight up PEBA, and it was either 80A or 85A PEBA. And I just wanted to test it by printing out this little armband here, and it came out really clean, very clean. I had to go into the slicer, and in the slicer, the only flexible option I was able to find was TPU 95A. So I just went along with that. I printed this out, and this turned out really, really good. It was very clean, and it just sort of snaps on to your wrist. There we go. Always takes me a while to connect things by myself on my wrist. But yeah, this is something that you could, customize text to be on this as well. And that kind of goes into this other feature that they're talking about this printer. It's called substrate printing, in which you take a flat physical object and you put that on the print bed, and then you can slice something else that does not require supports, and then you can print that object on top of the physical object that you've already put down on the print bed. And they have instructions on their website to show you exactly what you have to do in order to pull that off. And I think that's something that you could do with something like this. I think it'd be better something if it was bigger. I've seen like phone cases that have that type of feature enabled. But yeah, this came out really good, and I do like this. And if you were to make these in different colors, different writings on them, and you're using something like a 85A flexible filament, I think that this would be perfect for something like that. And then I also printed a phone case for my wife, who is getting an iPhone 17 Pro Max. So I'm like, hey, let's print a case using that same PEBA filament. And it did require some support, so I decided to load up some regular PLA in the right extruder and use that as support for the PEBA. Wasn't too sure how it would turn out. It held up a little bit, but it turns out that PLA and PEBA don't necessarily stick too well together. So it held up good enough for the print to be completed. But then after that, removing the PLA from the PEBA was just really super easy. It was literally just like wiping it off as if it were like filament dust, because it just didn't stick as well. And I guess that's just a thing with PEBA. Let's just take a look at what it already managed to print inside of here. And these are Christmas ornaments. I've decided to have nothing but 3D printed ornaments on my tree this year. And I'm just going to pop off these, at least a couple of them. But as I look at them, I mean, they're not bad. The shapes are looking the exact same. And then if I grab the other model that was on the other extruder and just compare the left to the right, again, we got a little bit of stringing there. They line up pretty perfectly, pretty spot on. They are lining up pretty darn good. And just looking at the surface finish of these, it's fine. It's a fine surface quality. I did not enable the ironing this time around. I think what I like most about this printer is the flexible filament auxiliary feeder because it's pretty nice to be able to print a wide range of flexible materials with various shore hardness attributes all the way down to 80A. And the IDEX system can be used in conjunction with that to provide support material, or you can even do some dual color TPU or pepper prints if you like. And that IDEX system also has its uses, especially if you want to print more than one copy of an object that's in a different color, because it saves you more time in the long run because you don't have to worry about starting completely different print jobs for each material. So if you're going to print 4 things, you can actually print 8 of them in the same time that you would be able to print 4 on other printers. An Idea Maker, the slicer, is new to me, but all the standard slicing options are still there. I just have to look for them. And to me, the software has been pretty stable and it easily connects to the printer for remote observation and control. And also kudos on the camera positioning as well. It gives you a bird's eye view and the frame rate is also pretty high. So it's almost like looking at it in real time. And it's better than a lot of the other cameras that I've seen on 3D printers. That's going to do it for now. I want to thank you all so much for watching. Until next time, take care of yourselves and I'll speak to you soon.